So we start Unit 2 today, and Unit 2 is all about sketching. So we're going to learn to draw different types of sketches that we can use as a way to communicate between team members. If I have an idea for a product, I need to express that idea in drawing format, I can do a sketch to do that. We're going to start with isometric and oblique pictorials. So those who are keeping up in their notebook, today is September 14th, and this is going to be notes on isometric and oblique pictorials. So a pictorial defined as a two-dimensional illustration of a three-dimensional object. So I take an object that's it's 3D, and I draw it with a two-dimensional illustration. It's going to show the three faces of an object within one view. And the three types that we will focus on in this class are isometric, oblique, and perspective. All of them provide a somewhat realistic view of the object. Some are more realistic than others, and they're each created slightly differently. So again, we have isometric, oblique, and perspective. So we're going to start with oblique then. An oblique pictorial starts with a straight-on view of one of the object's faces, which is often the front view. So like the previous sketching activities we did where we drew the front view of an object, for an oblique we'll start by drawing the front view. And once that's drawn, then we would draw angled parallel lines from each of the sides to represent the depth of the object. So create the front view, and then each of those edges gets pulled back to represent depth. And the common angles that we would use would be 30, 45, and 60. Since we have grid paper, isometric paper, we can either do 30 or 45 degrees for the isometric drawings, but with yours, since our grid is already in the notebook, if I draw from one corner of the grid to the other, it gives me a 45-degree angle, so we'll probably do that for the oblique. So if this is where the object that we wanted to draw, I have the front view that I would identify first. So this surface, and these two blocks I draw flat, and then everything else gets projected back or pulled back at, in this case, a 45-degree angle to represent depth for this object. There are two types of obliques that we will focus on, cavalier and cabinet oblique. The only difference between the two is the depth, how the depth is represented on that drawing. For a cavalier oblique, we show the full depth of an object. Meaning in this case, if the depth were supposed to be 2 inches deep, we would draw it as 2 inches deep. For a cabinet oblique, the only difference again is the depth, and that number gets cut in half. So on this example, if it was 2 inches, for a cabinet oblique, I cut that dimension in half to be 1 inch. Okay. People ask, well, why do that? Why would you not draw the actual size of the object when it comes to depth, especially if you're doing the true height and the true width, or the full height and the full width of that object? The reason for it is that drawing the cabinet is going to make it look more realistic. If I were drawing, let's say, one wooden cube, and I look at the two drawings, this one doesn't look as realistic as the cabinet oblique. It looks like it's stretched out longer than it should be. It looks more like rectangular than it does like a perfect cube. Whereas this one, where the depth has been cut in half, looks a little bit more realistic. So a lot of times we would go with a cabinet oblique to make the 3D drawing look more like the actual object. So again, the only difference between the two has to do with the depth. Half the original size of the depth is what gets drawn for a cabinet oblique. So the following few slides are an example or a way to draw this object, this little L shape of wooden cubes, as an oblique drawing. We're going to use what's called like a glass box method or a box method, meaning I would envision the size of the box that this object would fit in. So if I were, let's say, shipping it, what size of box would it need to be to do that? And we use the size of the object itself, so the overall height of 3 units, the overall width of 2 units, and a depth of 1 unit to determine the size of my box. So I'm going to start by drawing that box. The red lines that I'm showing here are called construction lines. Construction lines are drawn very, very lightly. It's not part of the final drawing, it's just what I use to create the final drawing. And so if I had to erase this, I would want it to be light enough that I could do that. Complete the box by sketching depth lines to the overall depth of the object. So in this case, our depth is 1, so I'm showing here. Repeat the process for a cabinet oblique. The front view is the same size. There's no difference for the full height and full width. It's the depth that's going to be cut in half this time. Now I'm going to focus on surfaces of this object that would be touching the surfaces of my box. So my front view, this surface would touch the front of my box, and I'm going to draw that on here. And if I look at the next, the top surface is going to be touching the top of my box, so I'm going to draw that on here. And then same thing for the right view. All of these, again, are construction lines, very light lines because they're not part of the final drawing. From here, I'm going to use object lines. Object lines are the darker lines, the finished edge or the finished drawing line, and darken in those surfaces that are part of the final drawing. Now I'm going to sketch additional construction lines to identify edges of the object inside the box. So these are all the faces touching the outside, but I have some faces inside the box. Using my construction lines to draw those, and then I'll darken those in as well. This process gets repeated for cabinet oblique. The only difference, again, is going to be that the depth has been cut in half. And our last step is to add what's called tonal shading, and that's used basically to make it look more realistic or enhance the appearance of our two-dimensional drawing. And we'll talk a little bit more about that in the next type of drawing. Here's some examples of obliques. All right, the next type that we're going to talk about is isometric. Isometric we're going to use most often in this class. A lot of times when we do the drawings to represent something, we do an isometric pictorial. The term isometric means equal measure. And we see that when I look at a drawing that all the angles here are exactly the same or equal measurements. The three adjacent faces on a cube will share one single point, which is what I see in here. And instead of dealing with the front face of the object like we did the oblique, we're dealing with the front edge, meaning the edge that would be closest to us as far as distance of the way that we're seeing it. These three edges then would represent the height of the object, the width, and the depth for my object. If this is the example of what we were drawing, it would be this edge here that would be the closest to me that I would focus on. Just like we did in previous activities where we had to identify the front view, we'll do the same thing here. This PowerPoint talks about the actual criteria that we use to do that. So if I wanted to select the best front view for an object, what criteria am I looking at to do that? Well, something that has the most natural position or use, shows the best shape and contour characteristics. We talked about the auto blocks car, like what is normally called the side is probably the best front view because it shows the contour. Longest dimensions, fewest hidden lines, and most stable and natural position. So if this were the object that I wanted to draw, I would select this as my front view because it meets the criteria that we talked about. Best shape description, longest dimension, most natural position, and no hidden edges. Again, we're going to use the box method just like we did for the obliques to draw this. So the box I can envision that would fit this object in it is a good starting point. It's almost like training wheels. Some of you will not need the box to do these drawings. You can just draw what you see. But if you do need or you're struggling, need help or you're struggling with it, I would recommend using the box method. We do want to be very careful about our proportion in estimation. We do have isometric graph paper, which will help, because the lines are drawn specifically at 30-degree angles so that we can avoid these types of drawings here. So, first example then of creating an isometric view of an object. If this is what we were creating, remember we identified this as the front view. I'm going to draw the box that this object would fit in. So I'm counting, 1, 2, 3, 4, 5, 6 is the overall width. 1, 2, 3, 4, 5, 6 is the overall width of my box. Has a height of 3 and a depth that appears to be 1.5. Again, I'm going to use points and construction lines to identify corners and edges of the object faces that occur on the box surface. So again, if I count 1, 2, 3 on the top, 1, 2, 3 on the top, and I'm going to use construction lines, very light lines, to draw where those are going to be. Then I'm going to darken those in with object lines. And then in this case, there are no interior faces that haven't been drawn, so I'm done. There's nothing on the inside that I have to worry about. And again, I'm going to add tonal shading. So the idea behind tonal shading is I select where a light source is. In this case, it's above, maybe behind the object a little bit. And then I add shading based on that. So I have one surface that's completely white or no shading, one that has a little bit of shading, and one that's a little bit darker than that. So I have 3 different tones to make the object look a little bit more realistic. Here's another example. Same idea, I'm going to use the box method. I have to count the overall width, depth, and height for this to determine the size of my box. So let's imagine these as individual cubes. So the width would be 3, my depth is 2, and my height is 2. That's 3 units wide, 2 units tall, and 2 units deep. Draw the box that would represent that. So 3 units wide, 2 tall, and 2 deep. Then I'm going to worry about the surfaces that are touching the outside edges of the box first. So from the top, I have these 2 cubes that are in the back corner. I've marked where those are on the top of my box. Do the same thing for the front and for the right side. I'm going to darken these in. And then worry about the interior edges and surfaces that are not touching the outside edge of the box. I'm using construction lines to draw each of those. I'm going to darken those in as well. Finally, we're adding tonal shading to finish the drawing off. And this is the way I would recommend doing it. Rather than completely shading it all the way in, if I use little kind of cross-section lines, and the more lines I add, the darker it's going to look. And so I have a white surface, one that has some lines here, a little bit more lines here, and that's a great way to do the tonal shading for the object. This would be a nice example of a common item that we've drawn before, maybe as a front view, drawn as an isometric using the grid paper and adding the shading. All right, so let's talk about today's actual activity then. We're going to be doing activity 2.1 isometric sketching. We're going to use the isometric grid paper that I have for you. So this won't go directly in the notebook. We'll do it on the isometric paper first. And we're going to practice drawing these isometrics. In this first example here, they've given you kind of a starting point to identify, okay, I can connect G to H, this is going to go here. So these are training wheels basically for this first attempt at drawing an isometric. But I want to recreate this object on isometric graph paper, adding the tonal shading when I'm done. The next 3, so number 2, 3, and 4, again, we're drawing as isometrics. The fact that these have been divided up into cubes is simply so that we can count or determine the overall width, height, and depth, but you don't need to draw them as if these are a bunch of individual cubes. Draw it as one solid object. Same for number 3, same for number 4. 5 and 6, same process, and then number 7, you'll pick the type of object that you want to do as an isometric. I would pick something fairly geometric, something that would be simple to draw. This is not an all-inclusive list, so if you have something that's not on this list, you can do that as well. There are 3 conclusion questions that also need to be completed for this activity. When we finish the sketches, I'll have you cut those out. We'll put those in the notebook, and then we'll be able to submit them. So all 7 sketches in the notebook, along with the 3 conclusion questions, will be submitted for 2.1 isometric sketching.